You know, people sometimes ask me how I learned to think the way I do. They assume there's some secret, some trick I picked up somewhere. But the truth is, I don't think I'm particularly smart. What? I did learn, though, and this took me years to figure out, is that most people don't actually think, they just accept. Let me tell you what I mean by that. When I was a boy, maybe 10 or 11 years old, my father used to take me for walks. In the Catskill Mountains, we'd walk through the woods, and he'd point at birds. One day he pointed at a bird and said, "See that bird? In Italian, it's called a chutotolapida. In Portuguese, it's bombed. In Chinese, it's chung, longta." Then he'd pause and say, "Now, you know in all those languages what that bird is called, but you still don't know anything about the bird. You only know what people call it in different places. I mean, now that bird, if you watch it, you'll notice it's always pecking at its feathers. Why? Because there are lice that eat the protein in the feathers, and the bird has to clean them off. The lice eat the protein. They lay eggs. More lice come. The bird spends half its time just staying clean. That lesson stuck with me my whole life. Knowing the name of something is not the same as knowing something. And most of what we call education is really just learning. Names, learning labels. But thinking, real thinking, means asking what's actually happening. I noticed this later when I was at MIT and Princeton, sitting in advanced physics classes with some of the smartest students in the country. We'd be learning about, say, quantum mechanics or electromagnetic theory. The professor would write equations on the board, beautiful equations, and everyone would copy them down carefully into their notebooks. Then, at the end of class, someone would raise their hand and ask, "Professor, what does this equation mean?" And the professor would explain it again using different symbols, different mathematical language. And the student would nod, satisfied. But I'd sit there thinking, wait, what does it mean? Not what does the equation say? What's actually happening in the real world that this equation describes? See, there's a difference between knowing something and understanding something. And most people, even very educated people, confuse the two. They think because they can repeat what they've been told, because they can pass a test, because they know the technical terms that they understand, but they don't. I'll give you an example. After the war, I worked on the atomic bomb project at Los Alamos. I went to Brazil to teach physics at the university in Rio. Wonderful place, beautiful students, very serious about their education. But I noticed something strange. These students could recite entire textbooks. They'd memorized everything. But when I'd ask them a simple question like, what happens if I shine light through a Polaroid filter at a certain angle? They couldn't answer. They'd never thought about it. They only knew what the book said would happen, not why it happened or what it meant. I started asking them questions differently. I'd say, forget the textbook. You're walking on the beach and the sun is reflecting off the water. Why is that reflection brighter from certain angles? They couldn't answer. They didn't have the habit of thinking about the world around them. They had the habit of memorizing what they were told. That's when I realized something important. Thinking isn't a talent you're born with. It's a habit. You build. And most people never build that habit because nobody teaches them. How? So, how do you build it? How do you train your brain to actually think? Instead of just accept, the first thing I learned to do, and I did this naturally as a kid without realizing it, was to always translate what I was learning into something I could see or touch or imagine. When someone told me about atoms, I didn't. Just memorize atoms are small particles that make up matter. I'd picture them. I'd imagine them bouncing around, colliding with each other. I'd ask myself if I had tiny eyes and could watch atoms, what would I see? Later, when I was studying physics at MIT, I did the same thing with equations. People thought I was slow because while they were racing through problem sets, I'd sit there sometimes for hours just staring at an equation, but I wasn't. Being slow, I was translating. I was asking myself, what is this equation? Actually describing, if I could watch this happen in real life, what would I? See? Sometimes I'd even invent strange little scenarios, like when I was learning about electromagnetic fields. I imagined I was the size of an electron floating in space. What would I feel if another charge came near me? How would I know? What would push or pull on me? This sounds childish maybe, but it worked because once I could see it in my head, I understood it. And once I understood it, I never forgot it. Here's the thing. Nobody tells you you can't. Think clearly about something you can't. Visualize. And most people skip that step. They learn the abstraction first, the formula, the technical term, the theory, and they never bother to connect it to anything real. So it just floats in their head, disconnected, meaningless. And then they wonder why. They forget everything a week after the exam. The second thing I learned, and this took me longer, was to always ask, why? Not just once, but over and over. Like a child. Children are actually brilliant at this. They'll ask you why. The sky is blue, and you'll say, because of the way light scatters in the atmosphere. And they'll say, why does light scatter? And you'll say, because air molecules are small. And interact with light waves, and they'll say, why do they interact? And they keep going until you finally admit you don't actually know. We lose that somewhere. We get embarrassed to ask basic questions. We don't want to look stupid. So we just nod and pretend we understand. But that's a disaster. Because if you don't understand the foundation, everything built on top of, it is shaky. I remember once I was teaching at Caltech and a student came to me confused about quantum mechanics. He said, I don't understand the uncertainty principle. And I said, okay, explain to me what you think it means. And he started reciting the textbook definition, something about position and momentum and Planck's constant. And I stopped him and said, no, don't tell me what the book says. Tell me what you think is happening. And he couldn't. He literally couldn't tell me because he'd never thought about it. He just memorized it. So we sat down and I said, let's start simple. Forget quantum mechanics for a second, if you wanted to. Measure where something is like a ball. What would you have to do? And he said, look at it. And I said, right. And how do you look at something? And we went through it. Light bounces off the ball, enters your eye. You see where it is. And I said, now, what if the ball is really, really small? So small that the light you use to look at it actually pushes it when it bounces off. And you could see his face change. He got it. Not because I gave him a better definition, but because he finally thought about what was actually happening. This is the secret. If there is one, don't accept anything until you can explain it to yourself in your own words, using your own pictures, your own analogies. If you can't do that, you don't understand it yet. And that's okay, but don't pretend you do. The third thing, and this is maybe the most important, is that I learned not to be afraid of not knowing. This sounds simple, but it's not. Most people are terrified of admitting they don't understand something. They think it makes them look dumb, so they fake it. They nod along. They use the right words, even though they don't really know what those words mean. But here's what I figured out. The smartest thing you can do is admit when you don't know something. Because once you admit it, you can start actually learning it. But if you pretend you already know it, you're stuck. You stop asking questions. You stop thinking. I used to sit in seminars at Princeton and Caltech where some famous physicist would give a talk, really technical, really advanced, and everyone would sit there nodding like they understood every word, and maybe some of them did, but I didn't always understand. So I'd raise my hand and ask a basic question, and sometimes people would look at me like I was simple. But you know what? Half the time, after I asked, 3 other people would come up to me afterward and say, thank. God, you asked that. I didn't understand either. The truth is, a lot of what passes for expertise is just people pretending. They've learned the language. They know which words to use, but they don't actually understand what they're talking about. And you can tell if you listen carefully, because when you ask them to explain it simply, they can't. They retreat into jargon. They make it sound complicated because they themselves are confused. So I made a rule for myself. If I can't explain something to a freshman or to a child or to someone with no background in the subject, then I don't really understand it myself. And that's okay. That just means I need to think about it more. There's one more thing, and this might sound strange, but it's been useful for me. I learned to enjoy not knowing, to actually find it exciting when I encounter something I don't understand, because that means there's something new to figure out, something new to play with. When I was at Los Alamos during the war, we were all working incredibly hard, long hours, high pressure. We were building a bomb, after all, and I was getting burned out. I felt like physics had become this heavy, serious thing, just equations and problems and pressure. So afterward, when I went back to Cornell, I decided I was just going to play. I wasn't going to worry about doing important work or publishing important papers. I was just going to think about whatever seemed interesting. And one day, I was in the cafeteria, and some kid threw a plate in the air, and I noticed the plate was wobbling as it spun, and there was a blue medallion on the plate, Cornell's logo, and I noticed that the medallion was rotating faster than the plate was wobbling, and I thought, I wonder why. So I went back to my office, and just for fun, I worked out the equations. Why does the plate wobble that way? What's the relationship between the wobble and the spin? And it turned out to be connected to some deep principles of rotation and angular momentum. And that little problem, that silly thing I did just because it seemed fun, eventually led to work that contributed to my Nobel Prize years later. But I didn't know that at the time. I wasn't trying to do important work. I was just playing. I was just curious. And I think that's maybe the real secret, if I'm being honest. You don't force your brain to think like a genius. You just let yourself be curious like a child. You ask questions. You try to see what's really happening instead of just accepting what you're told. You admit when you don't understand something and you keep thinking about it until you do. Most people stop themselves before they even start. They think, oh, that's too complicated for me. or I'm not smart enough to understand that, or I'll just trust the experts. But understanding isn't about being smart. It's about being persistent. It's about caring. Enough to actually think about something instead of just accepting it. I've spent my whole life around the smartest people in the world. Nobel Prize winners, brilliant mathematicians, incredible physicists. And you know what? Some of them were genuinely brilliant, but most of them were just people who never stopped asking questions, who never accepted something just because everyone else did, who kept thinking about problems even when everyone else had, moved on. You can do that. Anyone can do that. You don't need to be special. You just need to care enough to try. So, next time someone tells you something, anything, doesn't matter what, don't. Just accept it. Ask yourself, what does that actually mean? Can I picture it? Can I explain it to someone else in my own words? If not, then I don't really understand it yet. And that's okay. That's just where the thinking begins.